Here. This short video is to give a simple demonstration that GPS receivers receive their signals from overhead rather than from ground waves from ground-based antennas. What I'm going to do is take my handheld GPS receiver, this is a Magellan Sport Track Pro, and mount it out on my dock that sticks about 60 feet out from the shore into the water. And I will set the camera up to view the display for about 10 minutes. And what you'll see is that the number of satellite signals received from individual satellites change over time, as well as the signal levels. And I will be letting the camera monitor the display for around 10 minutes, so you can see how things will change over a 10-minute period. Then, near the end of the video, about the last 2 minutes, I'm going to hold a shield on and off above, about 2 feet above the receiver. What the shield will be is this FR4 copper-clad PC board material. It's 15 inches by 20 inches. It's 1/16 of an inch thick with fiberglass sandwiched between two couple mil layers of copper clad. And I will be holding it up about like this, and you'll see how that the signal changes when the shield is applied above and taken away from the GPS receiver. So basically what will be going on is the GPS receiver will be sitting here, and we'll have the shield above it, and most of the signals that are coming from overhead from satellite will be coming down to the copper clad and reflecting back off. Very little, if any, will penetrate through the barrier. However, there will be satellites over closer to the horizon that can make it to the GPS receiver, and you will see those signals. But you'll see that there is a dramatic change when the shield is up above, shielding the satellites that are more direct above the GPS receiver. The angle here that you're going to have an angle of view when I hold the shield about 2 feet above is about a 40-degree angle. So anything from horizon to 40 degrees will be able to make it to the GPS receiver. Now, if all the GPS signals were ground-based, with ground-based towers, we would expect that the signal would not change very much or at all when I put the shield up, because any signals coming from ground-based towers will be ground waves coming in, and they will not be shielded by this shield up above the GPS receiver. So if this shield is applied and taken away, you would not expect the signal levels to change or the number of signals from independent GPS transmitters to change at all if they are all ground-based towers. But you'll see that indeed when the shield is up above, it does change the number of signals received and their intensities, which will give us an idea that the GPS signals are coming from overhead from satellites rather than ground-based towers. So I'm going to go ahead and take this outside and monitor the display. Now what you'll see in the display are two circles, and these two circles will have numbers which correspond to GPS satellites. They'll be, and if you watch, they will dance around. Different satellites will come in and out of view, and then below it there will be 4 signal line levels. And what you'll see are histograms of the signal strength from individual satellites or the GPS transmitters. So you'll see something like this and these will change over time, the number and the intensity. And that's the thing to watch for, are the individual satellite signal strengths which are below this circle on the GPS display. So I'm now going to take this outside and set this up for about a 10-minute viewing. Today is Saturday, May 19th, 2018. I'm looking out over the target range that I had set up this past winter for measuring refractive effects and curvature of the Earth. Just to the right of the center screen we see the Franzen Island channel marker. That's out at 2.72 miles. And in the center of the screen you can see a little white dot. That is the 6-mile home island target. I left that up on the island because it's mounted in a tree there, but the other targets, of course, I had to take down because they were mounted in the ice. Rainy Lake is currently ice-free. We now are in summer mode. Show you some of the work I've got going on here. Got my bobcat where I've been loading rocks into these dock cribs. Have the stringers out on the cribs that will be attached to the cribs, and then decking put on top. And this section of dock will tie into my main dock, which is 60 foot long, that will be going to where I have my GPS receiver set up. You can see that we have a very nice clear day. Have unobstructed views to the satellites for the GPS. We'll be monitoring the GPS signal strengths here over a period of 10-12 minutes. That's the Canadian shore. And that's out in that direction at 6 miles, and that continuously changes to where we're out at 2.5 miles to that shore. And then we go back to about 4 miles to the west. So have quite an unobstructed view. Go down to the dock here. These are my dock stringers for finishing up the dock and some of the decking. And can see another view of the dock cribs. And this dock, that's the unfinished dock here, will be tied into this main dock going out that way. And the GPS is set up over here. It's been on a while, so it's stabilized. There's the GPS. And I'll set the camera down and we'll zoom in and just monitor the GPS signal for the next 10 minutes. Okay, I'm back. Now I'm going to put a shield over the top of the GPS, about 2 feet above it. And we'll see what happens to the signals. Now I'll remove the shield. Put the shield back up. Remove the shield again. One more time. Now I'll zoom out so you can see the shield. So we see here is a copper shield, and I go in on the GPS, put the shield over the top. You can see that the signals disappear, and I remove the shield and the signals come back. This would not happen if the GPS signals were ground based on towers, because the signals would be able to come in through the sides, but by putting the shield up over the top, it blocks any signal from coming in, or most of the signals anyway, from coming in from the sky.